All right, so before we go into conditionals, which will be the main topic for this video and probably next couple videos, before we get into that, what I want to do is a little bit of house cleaning on our project here and sort of show you how you can arrange things into folders and keep things nice and neat and clean, because, well, might as well do it now because later on down the line it will be a little bit distracting and potentially unwieldy. So let's just get this out of the way. What we'll want to do first is create a folder here in the assets pane. So right click and select folder. And let's call this script. So we'll put all of our scripts in that folder and just take all of our scripts. I'm holding Control and clicking on all of my scripts and drag it to our scripts folder. You can also drag it here on the left side of the pane as well. So I'll also want to create a folder for our images, put those in their own folder, and one for scenes, which, as I mentioned earlier, is kind of like the levels, in Unity when we create levels. So that's pretty much that. So what I want to do also is I want to keep our test script here kind of separate and all the other test scripts that we write, which is basically dedicated to understanding the C# principles and isn't really meant to be in our final game project for our prototype game that we're developing. So let's just put that in its own folder, the test script that we have right now, label it something like tests, and put that there. And I also want to rename this to make it a little bit more specific. And what did it contain? It contained our code for showing you how to create variables and operations. So let's call that variables and operations. Kind of a big name there, but it's at least descriptive. And we'll open this up in Visual Studio and change the name of our class to variables and operations, because if you remember, I mentioned before, your class name has to be the same name as your script when it's attached to a game object. So just remember that. It's an easy thing to forget. So we'll save that, and actually I'll run it just to make sure I didn't make any mistakes, or just to show you that it shouldn't make any mistakes. Yep. All right, looks good. All right, so on to conditionals. Now, conditionals are a key cornerstone to just about all forms of programming. They're called conditionals because they create a sort of a branching in your code that says something like, on the condition of so-and-so being true, then do this, execute this block of code. So you get this kind of fork in the road or railroad track pathing that happens in your code that allows for more interesting and dynamic behavior. So the code can respond to the changing states within it and behave differently depending on those different states. So that behavior ultimately comes down to being whatever you determine to be in those conditional code blocks. So the most common conditional in C#, and certainly the most common that we'll be using in Unity, is the if statement, which takes the basic form of if, and then parentheses, this is true. If this evaluates true, the stuff that you write in the parentheses, then do this, a code block that comes right after inside of those squiggly brackets, right? So I'm going to put a bit of a stronger emphasis on describing if conditionals because you'll be relying on them fairly heavily in your coding within Unity in order to produce this dynamic functionality within your code. And it could just be the aspect of coding that you would do well to work extra hard to wrap your head around. But conditionals at their heart are quite simple, and let's demonstrate that by writing out a simple if statement. So what we'll want to do first is create a new script. Might as well put it in our test folder here. So right click, create C# script, and let's type in conditionals. Double click that, open it up in Visual Studio. And here we go. We have a brand new script that we can use to demonstrate conditionals. So what I want you to write is, we'll take out update. We don't need that. Actually, I'm going to rename it to a custom name. Let's call it run conditionals. And in start, let's actually call that method that we have yet to actually write the definition for. And well, as before, might as well take this stuff out. Remember, declutter it since we don't need it, and we're not going to talk about these elements just yet. And now let's write in our first basic conditional. So type in int x equals 100, and then that's our variable, and we're going to evaluate it now with conditional. So if x is equivalent to 100, then, so those squiggly brackets represent here underneath the if evaluation, then we want to output that to the debug log. The operands are equivalent. All right. All right, and that's our basic conditional there. Let's save it. And over here, remember, we're going to have to attach it to a game object in our game here. So we'll click and drag it there, and we will disable the variables and operation script because we don't really care about its output any longer. And clear that. There we go. We get the output. The operands are equivalent. All right, so there we get the output. The operands are equivalent because that evaluated as true. X is equivalent to 100. Now let's see what happens to this evaluation if we alter the value of x so it's not equivalent to 100. Let's make it 1000. And then go back to Unity. And there you go. It's not outputting that code block anymore. So it just ignores that entire code block that's responsible for outputting the message because the conditional evaluates as false. So it has to evaluate true in order to execute that code block, or else it just ignores whatever comes after that evaluation. So conditionals evaluate top down, just like the rest of our code. Our first evaluation starts with if, which is that part. And what's being evaluated as either true or false is the statement within the parentheses. So the only rule here is that you have to have some statement that can, in principle, evaluate as true or false. You can't just stick a string in there or a mathematical operation, right? So here we're doing the equivalence operation. We use the double equals operator, which isn't any kind of assignment operator like the equals operator, but rather a check for equivalence. That checks if what's on the left of the operator, the double equal sign, is the same as what's on the right of that operator. Now, we haven't really mentioned this yet, but we know what the operator is here because we talked about operators. It's the double equal sign, as I just mentioned. But the things that the operator operates on, not just here, but in all cases, are called the operands. So from now on, I'll try to refer to them as operands. Here, the x is the left operand, and 100 is the right operand that the operator, the double equals sign, operates on. All right? Just a little bit of, extra information there, but it might help you keep that clear in your mind. So again, we start from the top, and the first if statement evaluates whether or not the value stored in operand x is equivalent to the value in operand 100. If that's true, it executes this block of code immediately after the code in the squiggly curly braces, right? If it's not true, it just ignores that code block entirely as if it doesn't exist, and it moves on down to the next line of code, which here there's nothing. But if there was some code here, it would go and evaluate, or it would start looking at the next line. That's if it evaluates false. So sometimes, however, we want to evaluate other possibilities in the case that it evaluates as false. So you can do this with else statements. If the first if evaluates as false, instead of going on to the rest of your code, it can fall down to an else if statement. So let me demonstrate this with writing in this code. So we'll add in an else clause, in case the if evaluates as false. So type in debug log, the operands are not equivalent. Save that. And run our game. The operands are not equivalent. So there you go. It evaluates the first if, finds that it's false, then it immediately goes to the else that evaluates as true, because of course x in this case is not equivalent to 100. So it goes on to the else, and that becomes a default that then does execute. So if we have lots of cascading possibilities, we sandwich in between the if and the else if statements. All right, so let's add in a simple else if. So let's go x is equivalent to 100 divided by 2, which will be 50. Type in x is equivalent to half of 100. All right. So let's just do this all again here. Let's put x back to 100 and then see the output. The operands are equivalent. Yep, that's what we were expecting. And now let's make it 50, which is going to then evaluate as true here. After it evaluates as false here, it will fall down to this. So let's try that out and show that in action. Yep, so that evaluates. And now doesn't have to be 1,000, it could be anything other than 100. We'll expect it to fall through to the final else clause if we now run it. And there you go. The operands are not equivalent. It falls down to the else, the final else. So if that first if evaluates as true, it skips entirely the next evaluations, the else if and the else. If it evaluates as false, then it moves down to the first else if. And then if that fails, the next else if you have more than one, you can certainly put in as many as you want. And this continues so on and so forth. And if all of those else ifs fail, then and only then does it execute that last clause, the final else at the bottom. It's sort of like a fail-safe or default, which says failing all of those possibilities, do this. All right, so that's what we get there. So it should be pretty clear that this is the only logical order that these conditionals can be ordered in. If at the very top, followed by else if you want, and at the very bottom, a final else, just one. So no other ordering really makes logical sense. Keep that in mind. You of course don't have to have an else if, as you've seen. You can just have an if, or an if and an else. Of course, an if, an else if, and then you should of course have a final else. And you could just use ifs, but you have to be very careful, because if you just have ifs, more than one might evaluate as true. You can get some kind of funky conflicting code, and in most cases it'll be apparent that you've probably made an error when some weird things are happening in your game. So that's just a simple first look at if conditionals. So this whole behavior of falling down to the next possibility, if the first if evaluates as false, it falls down to the else if it's there, otherwise it falls to the else. The way I would illustrate this behavior, to give you a little bit of a way of visualizing it, is imagine you poof into existence in a room at the top of a multi-story building called Chateau Conditional, right? Or perhaps Chateau Conditional or Conditional. I'm not really great with French. You could say that if you want, if you prefer fancier things. But in that room at the top of Chateau Conditional is a toll operator named Mr. If. And you're allowed to say exactly one statement to Mr. If. And Mr. If will simply reply telling you whether or not that statement is true or false. If he says true, great. You're allowed to go to the back of the room and open up this chest that executes that level's block of code, and then immediately leave the building, right? You're done with Chateau Conditional and Mr. If. However, if Mr. If says false, immediately under your feet, a trap door opens, forcing you down to the next level. That chest on the top level will remain unopened. If this building is 3 stories or more, then you meet on this next level, Mr. Else If. Mr. Else If looks exactly like Mr. If, and both he and the room and the chest function exactly the same as on Mr. If's level. And if Mr. Else If replies true, you open that chest and leave the building immediately thereafter. If he says false, again, you drop down through another trapdoor down to the next level, where you'll be greeted by another Mr. Else If to repeat this process. Or if it's mercifully the bottom floor, you finally get to Mr. Else, who is the exact same as all the other guys, except congratulations, you finally get out of this crazy building. He finally lets you out no matter what, even if it evaluates true or false. If it's true, you get to open that chest, but no matter what, you get to finally leave this nutty little building that we made up in our minds. Okay, so another thing about if statements, and that is you saw mathematical equivalence being evaluated in those if statements. But what about other common evaluations, such as greater than and less than, and other common mathematical concepts? Well, there are handy operators for those as well. So we'll show you them. Really simple stuff. So let's put this back to 100, and we'll comment out this code so we can preserve it in case we want to go back to it for whatever reason. And what we'll do is we'll write in another if statement. So if x is greater than 100, it's the greater sign, we'll write this. All right, it's pretty logical. Else all right, so let's save that and run it. X is less than 100, right? Does that make sense? Is that correct? No, it's not. We see that the evaluation occurred correctly. It checks if it's greater than 100, right? If it's not, then it goes to the else statement. So what's wrong here? Well, it's simple. If a value is not greater than a certain number, it isn't safe to say it's less than that number, because it might actually be that number, right? So for that, we have to write in the greater than or equals operator, which checks for if it's greater than or equivalent, the operands. I'll type in or equal to. Save that. There you go. And we can, of course, use the less than sign. It operates the exact same way. It's just the opposite of the greater than sign. So a few more things to say about if statements, including how in tandem with bools, they allow you to hold states in your code. This is functionality that is particularly useful for developing games. All right, so you're doing great. Keep following along, and I'll see you in the next video. Thanks.